So our objective up here, we're talking about permutations and combinations, and we just have this broad objective to count permutations and combinations, because eventually we want to talk about probability. And to do that, we have to know how many total ways there are to do something. So we had focused on Friday on permutations, and with permutations, order is always important. So if they talk about we need to arrange this, we need to place these in order, there's a first, second, third place. All of those things are going to be permutations because they're saying right off the bat the order is important. But what if it's not? And I had mentioned on Friday, if somebody from the yearbook staff came by and said, we're forming a committee to talk to people about, all the stuff that goes on in their math classes. Can you just give us 3 students to be on this committee? And I just picked 3 people. It wouldn't make any difference what order I picked those 3 people in, because in the committee they're all in the same standing. There is no order of, well, this first person that you pick will be the president, the second person will be the vice president, and the third person will be the treasurer. No, you're all of equal standing in that committee. When you're playing cards, you don't care if you get the ace immediately on the first round of the deal, or if you get the ace on the second round of the deal, or the third round of the deal. You just care that you got the ace. That's what you care about. So with cards, order doesn't matter. And that's the distinction that we have to make in today's stuff is which ones should we be using permutations for and which ones should we be using combinations for. And let me explain why. If they ask me to pick those committee members, and I say, I'm going to take Jack, Allie, and Cassandra. Those will be your committee members. And they say, well, no, you can't do that. Oh, wait a minute. Then I'll pick Cassandra, Allie, and Jack. They'd say, well, those are the same 3 people. Well, I already told you, you can't pick that group. Well, maybe there's a rule about you have to have 2 males and 1 female in each group or something, and we don't want that. So if I count those as 2 separate groups for the committees, Jack, Allie, and Cassandra, Allie, and Jack, I've just double counted all of the possibilities. In fact, I could make it worse and say, okay, well, I don't want those groups either. I'll have Allie, Jack, and Cassandra. All I'm really doing is taking the same 3 people and mixing them up in a different order. But order doesn't matter when you're talking about combinations. We just want to know how many are possible. So, spent a lot of time talking about the stuff where order was important. Dealt with factorial. Those that were gone, we've got a great button for this on the graphing calculator. And it is under math. And our factorial and all the good stuff we need for probability is right over here. And I'm just thinking I'm not going to be able to get away with that today because these people had asked me to record for them. I probably better use the calculator that's on the computer. And it'll slow it down, but we don't have a lot to go through in here today, so it's not going to be a big deal for us to use that. So the things that we want from that button: math, probability. We have talked about permutations. That was under there as well, and that nice factorial button that will tell us if we had 5 factorial. Will tell us what 5 times 4 times 3 times 2 times 1 is, and that's going to save us some time. So this button, we do a little exploring. You could either hit the right arrow, 1, 2, 3, 4, well, 3 times here for probability, or you could just hit the left arrow a couple times to get back there. But notice number 3, that's going to be our combinations. So if we don't want to do any of the math in our head, we don't have to, but as I told you before, if you're going to do anything with probability in college, you want to constantly start thinking in terms of factorial, and you want to think, how could I kind of cancel these things out without grabbing a graphing calculator? And that's just in case you punch something in wrong. So there was our factorial, and we talked about finding those permutations by using the graphing calculator, and now we're right here. So even those that are gone, hopefully you're feeling a little bit up to speed. So this says, look back at problem 3. What would happen if the first 3 runners advanced to the championship race? So here's what they're saying. There's a championship race at the end. So while it's great that you get first, second, or third place, the people that are going to go to that championship race are actually any of those first 3. So there's some strategy involved here. And if you watched the Olympics this summer, you know that. You know, David Phelps didn't necessarily win every heat that he was in when he was swimming. And that's because he was trying to conserve his energy for the championship. So as long as he got, first or second place, generally he was going to be in the championships. And so he didn't necessarily show all the speed that he had until he got to the end. That's just what they do. So they're saying here, what if the order of the first 3 is suddenly not important anymore? What if you just want to be one of those first 3? Well, if order is important, then you're not going to use permutations, because that's what permutations are for. So the order in which these finish no longer is an issue. They couldn't care less. They just want to be one of the top 3. All you have to do. So instead of a permutation, for that we use a combination. And one of the nice things about the names that they picked for these is it seems to be, to me anyway, that the letters that they start with helps you out with figuring out when to use them. For permutations, generally P tells us places. First, second, third place. There's going to be placings. And with combinations, we're talking about committees. We're talking about card games. Things that start with C that usually we'll use combinations for. So a selection in which order is not important. It does not matter. So this is the huge part of a committee. So if you have a word problem and you know they're going to ask you how many ways there are to do something, as you're reading through it, you want to think, okay, are they mentioning here anywhere whether or not order is important? And if they don't, then I can just use combinations. Now the number of combinations is not as high as the number of permutations, for the reason that I gave you before with the committee. Cassandra, Allie, and Jack all count as one committee. It doesn't matter what order they're in. So I'm not going to have 3 different ways to write that down. They are one committee. So there has to be some extra division with combinations to take out any double or triple counting when we go through that. And that's why combinations look a little more involved than our formula for permutations. This one, well, hopefully you noticed. I don't know, it's been a long 2 days here. Maybe everybody forgot. If you look at that, you'll see the n factorial and the n minus r factorial, which we had for permutations. But notice we now have r factorial to avoid any double or triple counting that we might do if we were trying to do a permutation. So counting 3 people for a committee. So with this one, we would say, well, 5 minus 3, that's going to be 2 factorial down here. The total is 5 factorial. 5 minus 3 gives us 2 factorial, but what avoids the double and triple counting is the 3 factorial. That's the piece that takes it. And then again, we want to think in terms of factorial. So at this point, you want to think, well, that's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. And realize there's a bunch of canceling we can do here. This 3, 2, and 1 are going to cancel right there. And then this 2 can cancel a little bit of that 4 up there. Well, 5 times 2 is 10. And then you maybe don't need a calculator to do that piece. But we certainly could. So we'll practice this one on the calculator with 5 choose 3. That's typically how we pronounce those combinations, is 5 choose 3. So we're going to go back to the main screen and tell the calculator that we want a 5 in that first position. And then math, probability, number 3, and we want 3 of those. And enter. So again, you would have to do any of the thinking through this. We're not going to give you a portion of the test that you could use a calculator on and a portion that you can't use a calculator on. So you could just use the calculator to get what you need. So with combinations, yeah, let's do a little practice here. It says, what is 13 choose 4? So this would be a word problem where they say you have 13 people and you want to pick 4 of them to be on a committee. How many ways are there to do that? So thinking through this by hand, I'm going to have 13 factorial on the top. Then I'm going to have 13 minus 4, which is 9 factorial. But to avoid the double counting, I also have to have a 4 factorial on there. Now here's what I'm thinking right away. With 13 factorial and 9 factorial, a whole lot of stuff is going to cancel out. Everything from 9 below. So really this would be 13 times 12 times 11 times 10 over 4 factorial. And so there's a little bit of canceling that you can do as you go through this and say, well, 4 times 3 is 12. So I'm going to cancel that right out of there. And 2 goes into 10 5 times. And then you can just punch in 13 times, pardon me, 13 times 11 times 5 and get your answer for that one. So there's 715, 13 times 11 times 5. Or you go ahead and punch it in, you know. It doesn't make any difference. We'll get the same answer. So if we go back to the calculator, 13, math, choose 4. There it is. So we do want an understanding of how factorial works. As I mentioned, when you get to college, it makes things go a lot faster if you're thinking in terms of factorial, and it makes the work go a lot faster. So why don't you go ahead and do got it for A, B, and C, and chicken wing and elbow partner, and we'll see what everybody gets. Mention what you want to do is at least write down this step, just in case you type it in wrong. And then you could use the graphic calculator if you want to, but that feel for factorial comes from, you know, literally writing things out and seeing what happens there. All right, 4B. Riley, what'd you get for 4B? 36. Sound right, everybody? Yeah. Okay, and then for C. Hallie, what'd you get for C? 3003. Sound right, everybody? Yeah, yeah. So again, doesn't hurt to get a feel for factorial and think to yourself, wait a minute, so this will really be 8 times 7 times 6, because the 5 factorial part will cancel out. This would be 3 times 2 times 1. Hey, that's 6. 8 times 7, answer's 56. It goes a lot faster than having to punch. I'm always slow with the graphing calculator, because if I'm not, then I end up punching things in wrong. So a little faster sometimes just to think through these in your noggin. All right, now, how are we supposed to know when to use which one? Well, you read the problem. That's what you do. And you try to figure out, is order important here? Are they saying president, vice president? Order's important. You know, we care who the president is versus the vice president. Are they saying first, second, and third place? You know, are they arranging? Any of those things would tell us we need to use a permutation. So for each situation, determine whether you should use a permutation or a combination and then find the answer. A chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? Is he given prizes for this? Does it say that anybody's drawing is going to be held to a higher level than anybody else's? This isn't permutations, this is just combinations here. Now to write the combinations, we need to know how many total he was choosing from. Did it say? 8 groups, so he's choosing from the 8. How many is he going to select? 4. So this would be 8 factorial over 8 minus 4 is 4 factorial, and then our n was 4 factorial. So I'm thinking, okay, that's going to be 8 times 7 times 6 times 5. But the 4, 3, 2, 1, and 0 would cancel out with one of these. So I'll have 4, 3, 2, and 1 down here. But this 4 and this 2 would make 8. So that'll be gone. And I could reduce that 6 to 2, 35 times 2. That's 70. That's 70 meters. Done. Or you write it down, you get this step down there, and you punch it into the calculator. And you get the same thing, but let's take a peek. 8. Math. Choose 4. There it is, you know? But it also kind of helps build up your confidence. Hey, did I do this right? Oh, look, I got all of that correct. Not 7. All right, so for B, I want you to just focus on, while I'm reading this, should this be permutation because order matters, or should we do combinations? You will draw winners from a total of 25 tickets in a raffle. The first ticket wins $100, the second ticket wins $50, the third ticket wins $10. And how many different ways can you draw the 3 winning tickets? Does order matter? You bet it matters. It's a difference in money. That's going to make a big difference. So order matters. So we better use permutations with this one. How many total tickets were out there? 25? How many are winning prizes? Just the 3. So this will be 25 factorial over, well, 25 minus 3 would be 22 factorial. So you kind of think in your head, wait a minute, 22 on down is going to cancel out. So this would be 25 times 24 times 23. That might be easier for you to punch in than punching it in as the graphing calculator would. However you want to do it. Did you punch it in yet? Once you get an answer, somebody speak up and tell us what this is. 13,800. Just out of curiosity, actually, did you punch it in this way or did you punch it in with the P key on the calculator? Okay. And like I said, for me, this would be much faster to punch it in because I don't have to leave that main window and try to find that permutation button. But either way, you'll get the same answer, 13,800. The got it says, in problem 5A, how many ways are possible for the teacher to select and arrange 4 drawings from left to right on the wall? Does order matter? Yeah, it said arrange. So now they really are like, oh, I like this one best, and I'm going to put the, even though it doesn't say that, you know that's probably what's going to happen. So we had 8 groups, right? And they are now arranging. So what should I use? Permutations. Should use a P. So 8 factorial over 8 minus 4 is 4 factorial. So we really just need 8 times 7 times 6 times 5. 7 times 30 is 210. 210 times 8. Oh, this was back in problem 5A. This was the chemistry teacher divides the class into 8 groups. So they're referencing back to that one. What you get? Oh, remember, with combinations, we have to avoid the double counting. So that's the reason there's another number under there. It's going to divide out anything that's been double counted, triple counted, quadruple counted. So when you're talking about committees, like we were earlier, I can't count Jack as one committee and count Allie, Jack, and Cassandra as a second committee or any of the other 3 combinations. So we have to divide that little piece out. What you get? 1,680. So our objective was to know the difference between permutations and combinations. I need somebody, so we can move on, to tell me how you know. How do you know the difference between a permutation and a combination? If order matters. Which one do you use if order matters? The P, the permutations. 4, 3, 2, 1, 0 me. How you feeling? All right, yes, the ninth grade number is going to be a little bit lower because you guys haven't seen this before, but with a little practice, I think you're going to be just fine. There is, date trees. Hold on, you'll finish this before you go. Sorry, I needed to get your test back, so that's nice every once in a while.
Yeah, it is.
Yeah. And have it not be difficult stuff. That helps.